Hi guys, it has been a long time that I post videos in YouTube. Coming to the vlog part, it is totally of 2 hours that I shooted the vlog because it is very controversy and even it's very hard to shoot there. So I guess every chemical engineer should watch this with full of patience, because this is the major thing that helps you to achieve the need of basic knowledge of chemical engineering. So that's the basic thing that I want to tell you before watching the video. And for juniors especially, there is a surprise for all the juniors. I think you will wait. Okay, so let's go to the video part. Babu ready, Babu. Hero Vamshi ready? Cameraman ready? Action!
History was wrong. Powerful people make places powerful.
I just started my journey from my home with lots of joy, encouragement and hope. Totally we are 10 members going to RFCL. After reaching the destination, we just took a home for a rent. Hello RFCL. Literally, I have no idea that how we just went in a single auto with 10 members. First day was all about everything, formalities of insurance policies and all. It's waste of time, and our first day experience was nice, and there's so much to learn here. Moreover, ammonia and wher fertilizer, the production was very unique here because so much of abroad stuff is there here. Nice. Need to explore more. Before moving into the practical exploration, we just need somewhat theoretical revision. So it's must. The first thing that we saw was the cooling towers and all the stuff of pipelines and all. We just got confused actually. So as an industry, you can see so many things here, and some of the leakages are also there. Here you can see, I think, here you can see the steam leakages, and these are also some of the major factors that affect the economy of our plant RFCL. And even you can see some steam leakages around some of the places also. I will show you one minute. So let me show you some vents which are used in chemical plant, that are steam vents. We call it as steam vent. So here you can see some of the steam vents. These are steam vents used. If there is any blockage in steam lines, there are some vents here. So here you can see the vents. So like that vents work. I did it. It was very vast experience here, and there are so many complicated ways to learn all these things, and it was so much hesitating to show all those things here because it was not that simple as we learn in classes, but so much complicated things are there. Those lines and those pipelines are so much hard to understand everything. It was very nice, but we can't assure that we need a minimum of 6 months training here for doing a job regarding chemical engineering stuff and all. It was tough, but it was a nice experience that I have ever seen here. Let's hope for the best. So we came to the end of the second day, the internship. So here we learned so many things here. Initially we learned about ammonia production, where we need the raw materials of end-to-end H2. So for end-to-end H2 we are using. So for end-to-end H2 we are using natural gas here, and from the natural gas we are taking mainly the most of the content of the natural gas contains methane. From there we are taking, with the help of the steam refining process, we are converting it to carbon monoxide, carbon dioxide, and also the part of hydrogen. And the nitrogen content we are taking from the air itself and the compressed air itself. And the process is very unique here because it was a different process regarding chemical technology. The same process as in the guidance book of chemical technology itself, but there is somewhat changes here, small types of changes. And comparing to theoretically and practically, there are some differences. Like most of the problems are there in practicality, so we don't have that much solutions in theoretically. So we need to do some of the calculations and some of the innovative things here, because in industries small energy is also not being wasted actually. So for that there is so much complication here. So the complicated systems will be very hard to understand, but it's much more economical for us and economical for the nation and economical for the board. That's how the day went. The ammonia production was good, and urea production we go, I think so in next 2 days we just go in depth of the ammonia production and the reaction basis and the rate of the reaction. Those all will also be carried out. After that we will go to the urea production plant. Nice experience, and need to learn more.
So this is how the burners burn inside the reformer.
Okay, here my friends will say something about this plant. Okay, here I have my friend Prem Kumar. He says about this cooling tower.
Cooling tower is RFCL plant. Very nice cooling tower.
They have
14 cooling tower. Yeah. Now
which type of cooling tower is this?
this is, now tell about this cooling tower, Shiva.
English intra.
Shiva, coming. First we have to talk about the lunch mess. They are giving 6 chapatis. 6 chapatil. Quantity is very good. 40 రూపాయలు మాత్రమే. పొద్దుగాల మధ్యాహ్నం సాయంత్రం 100 రూపాయలు సెట్.
చాలా మంచివాడురా, కాస్త ఆవేశం ఎక్కువ.
Okay, not about the food and all things, but it's a type of induced draft cooling tower which gives most of the efficiency in plant also. And
this is our first industrial visit. This is an awesome experience, and we learned a lot. This is good.
So this is the main difference that which we see in theoretically and practically. So in theoretical, what we have studied, we just studied about cooling means it should be done at the low temperatures, that which we feel very cool. But it's not like in industries. In industries, they use steam to cool the vessels and the reactors. So that's the main difference that which you see from theoretical and practical. So here you can see that they use the steam, compressed steam is used as a cooling agent for the reactor or a vessel or a reformer.
And the third day was somewhat nice. I asked that ammonia production manager about to find out the efficiency of the absorption tower of the CO2 in the plant, but he said that you have so much less time, only 15 days, so you can't export that much. So he said that take a brief of every aspect in this plant. Not only that, not only ammonia plant, on every eye basis, even captive power plant, urea formation, ammonia formation, and bias and packaging and those all things also. And that's all it went today.
So these are the distributed control system where all the plant is operated automatically at this place. So this will be always at the center position of the plant. From there they control every aspect, small parameters also, even the pressure, temperature and the compositions also they will control from here only. So it's all automated. So that's why only the staff is also very less in this RFCL as it is automated. I think there is some problem here. So these problems are common in industries. So we need to be very alert actually. So here you can see the cooling towers where the vapors are going out from the cooling towers.
And there you can see the cooling towers. In the cooling towers you can see the fans above them which suck the air from the bottom and push upwards, where mass transfer happens of the latent heat transfer of cold air and the hot fluid that is water. By that mass transfer happens.
So this is the nitrogen plant where they use cryogenic distillation process for production of nitrogen from the air itself. And as we know, cryogenic distillations happen at lower degree centigrades, so the temperature will be in negative. So that's why the nitrogen gas vents are used here.
Reservoir. We have two reservoirs here, 1 and 2. From here the water is taken to the clarifier. In the clarifier the water is the molecules in the water, which is called total suspended solids, will be settled down by fluctuation process. After that the pure water will float, and that water is sent to plant for treatment of reverse osmosis and filtration process. Those all processes will carry on, and demineralization also carry on by strong acid beds and weak acid beds where we have ions in it. So like that it will happen. And here is my friend Harnath will explain.
మనం మెయిన్గా ఈ వాటర్ దేని యూజ్ చేస్తామంటే ఫ్లాట్లో మొత్తమైన 4 టైప్స్ యూజ్ చేస్తాం. ఒకటి సర్వీస్ వాటర్, ఏంటి యూరియా రా మెటీరియల్స్ ఏంటి చెప్పండి. అమోనియాకి యూరియా కావాల్సిన రా మెటీరియల్స్ ఏంటి? వాటర్. నార్మల్గా మనకి స్టీమ్ జనరేషన్కి ఏం కావాలి? వాటర్ కావాలి. ఏ వాటర్ కావాలి? డిఎం వాటర్ అంటే డీమినరలైజ్ వాటర్. అసలు వాటర్ ఎందుకు డీమినరలైజ్ చేయాలి?
అడిగిన దానికి సమాధానం చెప్తే తెలివితేటలు అంటారు, చెప్పకపోతే పొగరంటారు. మరి నన్ను ఏం చేయమంటారు?
అందులో అదే వాటర్ ఎందుకు వాడాలి? కాబట్టి ఈ వాటర్ని ట్రీట్మెంట్ చేస్తారు ఇక్కడ ఈ ప్లాంట్లో. వాటర్ ట్రీట్మెంట్ ఎట్లా చేస్తారా? ఏం ఆడతారంట అట్లా అడిగిన
So from Godavari we get water here. These are the two reservoirs. In these reservoirs, the water is get stored, where so much of the solid particles will settle down, and from the top we will take all the pure water, and that pure water is sent to clarifier, where in the clarifier, by using the fluctuation process, adding some oil and those all things, the total suspended solids will settle down. After the settling of suspended solids, from there there is a pure, somewhat pure water will come with somewhat sulfur chlorides in them. That water is taken into DM plant, where it is known as demineralized plant. There, the demineralized plant has 4 types of beds, actually strong acid bed, weak acid bed, and weak base bed, strong base bed. In those beds, the ions are being separated. Like that, the minerals will be exhausted in the water. So then we get pure H2O. This H2O, this water is used as steam in the plant of refinery process, in the plant of reforming of ammonia and formation of urea also. Because why we need to demineralize the water means we need to demineralize because if there is any presence of iron or if there is a presence of algae in it, it will form corrosion in it. So for that process we will demineralize. Even we also do deaeration process also. Deaeration process also, because deaeration also, because the oxygen molecules also will have some effect on corrosion on the particles. So that's why we use. And here you can see some pumps. From here, from these pumps, it will circulate to the plant actually. So as we studied in our previous classes about heat transfer, so heat exchanger we use, and the same type of heat exchanger we will call it as condenser also. So here I think you can see there are 4 heat exchangers. In that 4 heat exchangers, 2 are not working actually. They came as a malfunctioning unit. So here we can see the tubes and how the tubes are arranged, how heat transfer will happen. I will show you. Let's come here. So here you can see some of the tubes actually. These are the tubes. So you can see the arrangement of tubes. The tubes are arranged in a triangular pitch format. So why they use triangular pitch format? Because of the more number of tubes can be fitted in a less area. So then the heat transfer area will be increased. So by the increase of heat transfer area, you can heat transfer. The rate of heat transfer will be more also. And even for here you can see there are 2 partitions. I think so. This is the first part and this is the second part. So by this you can say that it's a 1-2 pass heat exchanger. So this is a 2 pass. 2 times in tubes the fluid will be passed, and for 1 time through the cell will be passed. You can't see the cell because it was opened only on the side opening. So this is how the tubes are. And if you see inside the tube, you can see the lighting from outside. Here you can see the outside opening of the tube. That's how the length of the tube is. Come here, I will show you something. So here we have inside the shell side we have baffles also. So baffles are 75% circular, means in a circle if you remove the chord, how it will be, like that it will be. So baffles are used as holding of the tubes. So from here, if we consider on this total big heat exchanger, we have only some number of baffles. So the baffles will be in alternate places. In alternate places, the baffles are rearranged, means they will be reversed. If one baffle is in like this shape, another baffle will be in like this shape. So if we consider here, if it is a baffle, the opening of the baffle will be 25%. So from here, if we inlet the shell side water, the shell side water will come here and will go from the top of this, and again will go down. And if we consider another baffle, the another baffle will be of 75% closed here and 25% open here. So we can say that the water will come here the cooling water will come here and goes like this and goes like this in a S shape format. The cooling fluid will go and come out from here. So this is the shell side inlet. This is a shell side inlet or outlet, and there also you can see, and here also you can see at the bottom it's a shell side inlet or outlet. So you can consider both of the things. As this is a maintenance block. So we can see a heat exchanger like this. So is there anything to say? So these are the types of heat exchangers. These are big heat exchangers which are used for condensers or also heat exchangers. So like that, how our in industries how heat exchangers will be. This is totally rusted one. So they shifted to the maintenance block. So like that in industries, so many things will happen. I think you like the information. Thank you.